First of all, thank you very much for attending this talk. And my name is Pedro Machado. I'm currently senior lecturer at the Nottingham Trent University. And if you want to learn more about what I've been doing, you have the QR code here ready for you to look into my personal webpage. So today I'm going to quickly cover my research interests because we have to use any opportunity to expand / augment our network. And in case you are interested, by all means, do get in touch with me through my email. I'm also going to do a brief introduction to Docker. Then I'm going to do a Docker demo, and I will finish this talk with conclusions. As Paul mentioned, I would like to get the questions while I'm doing the presentation. So by all means, if you have any questions, do raise your hands and ask your question. We'll also have a Q&A session at the end of this presentation with about 10 to 15 minutes. So my research interests are around edge computing, neuromorphic engineering, robotics, sensors, and spatial neural networks. So I'm trying to collect data from the environment using a range of sensors and try to process that information while we go along. You have here a QR code that takes you to my UPD project and also to the IOW project. I'd like to use this opportunity before starting talking about Docker to thank to the IT department of my of the NTU because they have been doing outstanding work and they have been supporting me through the process of deploying Docker. So let's talk about Docker. What is Docker and why are we even speaking about Docker? So Docker, above all, is an open platform. This means that it's freely available to everyone, and it can run in popular 64-bit Linux distributions. Nowadays, it can also run in Windows, Mac OS. You'll have Docker available on most of the cloud service such as Amazon EC2, Google Computer Engine, Microsoft Azure, Rackspace, also Adobe, Oracle Cloud. So let's look at the features. Well, first of all, one of my favorites is a lightweight. So for example, you take around 10 minutes to start a virtual machine from the scratch. Okay, if you have a very good computer, it can take less than that, but normally it's in the scale of minutes. Docker, I normally take around 5 to 6 seconds to be able to start Docker. It's based on Linux containers, although there is already some containers running Microsoft Windows. But one of the reasons why Docker is so powerful is because it's based on Linux containers. And the good concept here is that you only have the minimum packets that are required to run Docker. For example, the Alpine version is as little as 5 megabytes, if I'm not mistaken here, okay? Uses layered file systems to save space, uses a copy on write file system to track changes, which is very useful. It's portable, can run on any Linux system, Windows or Mac OS. It contains edge device support. And I can give you an example. I used to work for a company, and one of the problems that we were facing at some point is that when we were deploying the system, sometimes the user would break the operating system, and especially when you have the edge devices, this can be a problem. So the solution that we found was to allow the user to work inside of a Docker container. This way, if the user for some reason break the container, we could easily deploy the container again and without losing the contact to the access to the machine. It contains a minimal base operating system, libraries and frameworks, and also contains application code, and a Docker container can run anywhere that Docker runs. And this is the one of the most powerful aspects. For example, I was able to deploy one of the images that I'm going to cover today on a Raspberry Pi because I do not have access to a Mac M1 or M2 or even a Chromebook. So, and this is something very, very helpful. Okay, well, the challenge is we have all of this service and we have our hardware. So how do we deploy these systems? So this is a very big challenge, because from the user perspective, the user doesn't need to know where the service is running. And at the same time, what the user needs to have access is to the full application where they can deploy their service. So the biggest question here is what and where? Where are we going to run all of this? Okay, in the past, we used to develop these monolithic application that were running on a specific machine. And if you need more resources, what you do was most likely to increase to buy another machine with a higher spec. These days, we can easily deploy having containers running in different machines, and then we create a connection between them and allow all of this service to work together. So let's look at this example. In the past, we have all of these goods, and we had to figure out the answer. Where, how are we going to transport this? Are we going to transport this by bus, by a ship, or by a truck? And how would we distribute that? So more or less, if you do this kind of analogy with Docker, you'll be able to quickly understand that it's possible to address these with Docker, because the way Docker, the simplicity that Docker offers. So again, we have this very complex matrix where we are not sure where, what, and where. Okay, so the question here is, where are we going to deploy a given service? Are we going to deploy on the same machine? Are we going to deploy on a different machine? So we have this massive problem. So how do we solve? Well, one of the ways that was solved in terms of a practical example was, okay, we just put our goods inside of a container, and then that container gets transported. For example, you have something that you bought, you just place the order, but then the supplier tries to organize everything, put everything inside of a container. So in the same container, you can have a mix of goods. For example, you can have a car, you can have some other goods, and then you just have to make sure that the service that you're going to use to deliver are compatible with this kind of container. So for example, if it's going by road, you have to have a truck. If it's going by rail, you have to make sure that the rail is big enough to be able to transport these containers. So the principle is simple. We want something that is packed into a container, and then we use one of these systems to deliver the container. Okay, so this is the concept that we have behind Docker. Okay, so you can you have the offer. Docker offers the flexibility of running, for example, everything on the same machine, or you can have multiple machines, and you, as long as they are connecting in the same network, and the containers can communicate between them. As long as you secure that, then your problem is solved. And there are many advantages. So, for example, if you want to update the database, it doesn't mean that you have to switch all your application. You can just switch off the container that contains the database, and at the same time, you can activate almost immediately the new container with the database deployed. So in other words, you don't need to completely switch off your service just because you want to update a container. Using this kind of approach, you can also use a Docker container to run tests. Normally, when you have to do tests, you do not want to ship your application with all of these tests. So you could just have a small container that you activate during the test phase, and you test all the application. And if the application gets successful, then you can just remove that container. And when you deploy on the cloud, you do not have to move that container. Another big advantage is nowadays Docker offers you an abstraction of the hardware. So, for example, making use of QEMU, you are able to emulate different architectures and be able to deploy and see how the application will behave. A big example where they currently using Docker is on the kernel. On the kernel, every time that they commit a new version of a kernel, they do, for example, a nightly integration. And what they do is they have different containers for different architectures to make sure that when they build, the kernel builds for all the Linux kernel can build for all the different architectures. So as you can see here, if you make use of containers, that you can easily integrate a network of very powerful devices, and you can even have a small mixture between high-performance computers and, for example, IoT devices, because as long as they are, as I explained, as long as they are in the same network, the service will work together, so you can just close the loop. Before moving into the next step, is there any questions that you may have? Now it's a good opportunity because I've been talking about Docker and there might be a specific question. No? So let's continue to look into the architecture. So why is Docker so so powerful? Well, Docker is the architecture is very simple, and the secret here is you can only for conquering you have to be able to build complex application. You have to be able to use very simple approaches. So Docker is a very minimized tool which sits on the top of LXC, and you're going to have your CLI, your Docker daemon, and your Docker register. At the same time, on the Docker Hub, which is a cloud service, and I left a link to my Docker Hub, you can share the applications, automate workflows, assemble hubs from components, and also you can share your Docker image. Another big advantage is when you build your container, the way Docker has structure is that it creates chunks. So, for example, if there is a new update of a container, the user or where it's running Docker doesn't have to download all the application, can just download the chunk that is relevant for that application. And I have an animation in the video where I was able to demonstrate just that. So again, the one of the reasons why it's so powerful is because it contains all the service and only the service that are required to run that particular service. So let's look at Docker image. So it's not a VHD, not a file system. So it uses a union file systems, a read-only layer that allows you to read. Do not have a state. Basically, is a tar file that is deployed and has an hierarchy. So it has an arbitrary depth. So it increases, it becomes almost elastic. It can increase or decrease based on the applications that are installed / removed, and fits into a Docker register. And this is particularly interesting. So for example, One of the containers that I've created was on a Raspberry Pi, and the Raspberry Pi that I use has around 1 gigabyte of memory. And it was interesting to be able to deploy a full system with a GUI and so on such a small device. This is only possible because of the footprint. Container is really, really small. Unlike a virtual machine where you have to define how big the image is going to be, Docker will only make use of the resources that are necessary. So, units of software delivery. So it's very nice for the concept ship it. So you can continue to develop your application and have multiple containers that you can have. So for example, when you sell a product, for example, when you sell your API, you could easily augment the functionality and the behavior delivered by that API by increasing the number of containers. So think about this. A client asks you to include an extra functionality. This extra functionality could be deployed on a container that is just shipped, and then you can activate for some customers and deactivate for other customers. And above all, is run everywhere. So regardless of the kernel version, regardless of host distribution. One of the examples where I've been using Docker is on the robotic operating systems. The robotic operating system is very sensitive to the version that you are running, and it's very easy to break the robotic operating system because you have installed a different version on one of the devices. And the problem, the way I found to solve that problem was, okay, instead of having running rows running on the host machine, I could just have the rows running on a container that access the broker and is able to exchange all of this message. And this way, even when you upgrade the operating system, you don't have the risk of breaking the installation. And even when you have a situation where it's running on a different architecture and you want to be able to understand how to run on a different architecture, well, Docker also offers that flexibility because nowadays you have containers with that are running QEMU, and you can use QEMU to emulate the architecture that you want to emulate. So this is how the containers looked before Docker. Everything was messy, everything was monolithic, everything running on the same machine, and it was very easy to have a situation where you actually could break the container because for some reason you remove a component or you deploy a piece of software that was not compatible with the previous versions. The other problem is that, because everything was almost a craft to work in that particular space, if you have to update a model, you could not you could have situations where you could not do all the tests that you had to do. Again, with QEMU, you can have QEMU and Docker. You can have you are able to test all of these without shipping into the customer. Okay, so let's look at how containers look after Docker. Everything is much more organized, everything is automatized, and it's very easy to be able to have more control on the software that you are deploying. Also, it becomes much more flexible. If you need more computational requirements, you can use any device that is out there and just add it to the same network, and it will be able to deploy your container. And from that moment on, there's another service, another functionality, another behavior that you are making available. So how does Docker work? Here I have this QR code in case you want to look into my repository. repository on Docker Hub. And if you open this QR code with your mobile phone, you'll be able to go to my repository, and you'll see that on my repository, you get all information in the Markdown. And you can build Docker image that holds your application. You can create Docker containers from those Docker image to run your applications. You can share those images via Docker Hub or you on a registry. For example, one of the problems that we were having here at the Nottingham Trent University was every time that you log in some computers, the containers get deleted. This happens especially on Windows. And it was taking about 20 to 25 minutes every time that my students were starting the session. And to improve the learning experience, what we did was to load the Docker container from an image, which was much faster when compared. So let's look at the virtual machine versus the container to better understand. You can see here that in this case, you have a server, you have a host operating system, and we have then the hypervisor. Then you have the guest OS, where you have to specify the size of the resource that you're going to require. For example, you have to specify I need 2 gigabytes. I need, for example, 100 gigabytes of hard disk space, and so on. Then you have your binary files and libraries, and then you have your applications, and you can have the application running side by side. Now, one of the problems that this approach has is, okay, you may run out of space on a machine, because when you were defining the amount of space that you are using, for example, you specified 2 gigabytes. In reality, you do not require those 2 gigabytes. You probably just need a quarter of that, and you don't need all of that space because the application was not using all of that space, but because you said specify that the hard disk drive is 1 gigabytes long, you are consuming the resources without actually being using those resources. Well, Docker solves that problem because it makes use of the resources available on the host machine, and also the space becomes elastic. So it increases if you install package, it will decrease if you reduce the package. Okay, so it gets a smaller footprint. So here's another example on how Docker is so efficient. Again, you have the guest operating system here after the hypervisor, and then you have binary and libraries and application A and application B. Now, the difference here is that it only contains the binaries and libraries that are required for those applications. And again, the big advantage here is that you have a very small footprint. Another flexibility that is very useful is, for example, you can define a base Docker container and then implement your image from that. And I'm going to show you that on the video that I'm going to demonstrate. Okay, so let's look at the Docker container lifecycle. Well, it starts on the conception, where you build an image from a Dockerfile. Then birth, when you start running, reproduction, when you commit and you run, sleep when you kill a running container for some reason, awake when you start by issuing the start, death when you remove and delete a stopped container, and extinction when you completely remove the image. So these are the main commands. So let's look at the Linux Cgroups, the kernel feature, and as you can see here, you're going to notice that the CPU usage, memory, disk, and input and output will be a smaller footprint. And here you can have multiple combinations on how you build your application. You can go for nest, you can have a completely parallelized. The good thing about all of these is that you can have user A accessing process A, user A accessing process 2, and so on. And the same machine will be able to be used in a much more sustainable way. Let's also looking at Linux kernel namespaces. So you can restrict your view. So in other words, you can augment the security. For example, if you are allowing someone to access your container, you can just give them access to a specific virtual space that is composed by one or more containers. And this way, the user will not have enough information about how the system actually works. And if they attack, if you have an attack, instead of attacking your host machine and you have to deploy everything from the scratch, you may have a situation where, when worst case scenario, they attack a container, and you can easily deploy a new version of that container with security increased. Another advantage is that you can have containers that have privileged and unprivileged access. So inside the container, they can have privileged access, but in the reality, on the host machine, they will not have privileged. Okay, so let's look at how the Docker file looks like. Well, this is a very simple file where you write your instructions. And it's very similar to a makefile. For those of you who have been working with makefiles for a long time, you'll see some similarity. So for example, in this case, let's look at the from. This means that you are going to use as the image Ubuntu 18.04 in this example. And then you can issue commands like copy, where you copy something that is in that particular folder into the /app inside the container. You can, for example, run make, and you can also run the commands, okay? So the results in a new Dockerfile, imperative, not declarative. Dockerfile lists the steps needed to build an image. This can be very useful. If you can inspect the Docker image, you'll have the Dockerfile. You'll have an understanding of everything is being installed. So if you want to look into vulnerabilities and so on, you can easily look what has been done and how. Docker build is used to run the Dockerfile, or to create the image from that file, and can define default commands for Docker to run, ports to expose, and etc. So if we look at the commands that we have available today, we'll see that we have all of these big list of commands, and these will most likely increase with the time. So these are the list of commands that you can get with a simple Docker if you run Docker. So let's now focus on how we can use Docker on higher educations. Well, so how do we train our students, okay? So if we want our students to be able to use these technologies, we have to be able to train them. How do we do that? How do we reduce installation and configuration times? Okay, just because it's difficult to configure the environment, that doesn't mean that we should ask our students to be spending their time with the installation and the configuration of the containers. And how do we offer the same development environment to all of our students? So, for example, I'll have students that have Macs. Some of them will have the M1 chip, some others will have the Intel ones, some others will have Windows 10, Windows 11, many flavors of Linux. So how do we create an environment where we offer the same environment to everyone without independent on the host machine? This is only possible if we have a very flexible way. For example, last academic year, I was using the virtual machines, but I had the problem. So any student with a Mac M1 will not be able to run the image. And it was a nightmare because just because we have virtual box, we have VMware, but even when we give them the instructions, I can see one hand up. You have a question.
Yes, we have a question from R. Anderson. I'm going to unmute.
Yes, can you run Docker in Alpine Linux, which is like a small footprint?
Yes. So
Okay.
even in Linux, you can run Docker. So for example, when I'm teaching my students to make sure that everything works as I described in the lab, instead of running the native software on my Linux machine, which I could do, I also run the same containers, and it takes me around 2 to 4 seconds to start Docker and to remote into the container.
Okay.
Okay. Any other questions? No. So here is an example on how we address the problem. So you can see here the 3 commands that we are currently running on our computers. Remember, some computers will delete the information after logging off. So I'm never sure if the image is available or not. So normally I ask my students to double check if they are, if it's there or not. But if not, we use this Docker load, and I provide as an input this file com281.docker, which is basically a tar file. Now here is a good approach, unless the computers that you are using are becoming a little bit obsolete, and if they have if they don't have enough resources, it's much easier to run the third line here. The third line, let me analyze this. So on this file, what I'm doing here is to run in the iterative mode, and I want to remove the image at the end, and I'm going to explain why. And I'm exposing the port 3390 on the host machine, and will be mapped into 3389 via TCP. This is the name of my container, and then I have a logic volume. So if you don't define a logic volume, you will lose the information unless you have a persistent image. And here I'm mapping this into the folder where the project is going to be stored. And finally, I have the repository name. So this connects directly to my repository on Docker Hub. And then this is it's called a tag, and I use the tags to define which model to run. Now, let me talk a little bit about this comment here. So the reason why I did this is because another skill that I'm teaching my students is help them to work always inside of a Git container. So in the first weeks, my idea is if you forget to commit the changes into a Docker container, then you are going to lose your job, your work, because the work will be removed at the end, because here I was removing the container at the end. So in other words, in the first weeks, it's a bit more frustrating for them, but helps them to develop good practice, which is using Git when they are working on a software project. So I'm now going to run a demo, and if you want to access my Docker repository, here is the QR code to my repository. If you want to run on your machine, independently on which machine you have to download the latest version of Docker, which you can do by going into docker.com/getdocker. Okay. If you want to run the same container, you have here the instructions. So if you have an MD64 or Intel 64 or your laptop, you can just run these 2 commands here. If you have an ARM64, for example, a Mac M1 or M2, you can run this one, okay? Although you can run these architectures on, for example, you can run an ARM64 architecture into an Intel 64 and vice versa, it will be slower, okay? So make sure that if you want to run these examples, you use the correct architecture for your machine. So I'm now going to, before starting the video, and the reason why I recorded the video was because I don't know if you are traveling or not while watching this session, and if you are having problems with me speaking, there will be a YouTube video here that you can check later on. So let me increase the size. Okay, so the first thing that you will see here is my Docker desktop, and here I have two images. I have COM281 and SOF 451. Both of these containers have the exact same tools, so they were designed to allow development of Java applications. So the first thing that I'm going to do is to press play, and then I'm going to RDP into this container. So I created a version where you have the XFC environment. So what you are, and I also installed XRDP so that you can connect into the machine and access. And you'll see here that all the software that is required for my students to do their work is already deployed here. So you can see here, for example, NetBeans on the bottom. And there are some more other tools that that are available. Again, one of the big advantages is that this way I was able to configure the environment. I know that all my students will be using NetBeans 15. They will also be using the Java version 19. So this way I'm making sure that whatever I do is going to work as expected. All the projects are stored in the NetBeans project. You can see here that we have NetBeans running. And to give an example how simple it is to use this approach, I'm just creating a new project and I'm going to write hello world. So let's do a simple hello world and run the application. Okay, finish. As you can see here, we have our hello world there. Next step is to build. And after that running, and you'll be able to see we have hello world there. So it was as simple as that. If you notice that it took me a couple of seconds to be able to get into this stage. I can see a hands up.
Yes, can you post a link to the video, YouTube video?
Yes, yes. So the demo is already available. Let me see if I can copy the link. Let me, I don't know. Okay, share. I'm trying to find chat. Okay, found the chat for everyone. Okay, you should be able to see the link on the chat. Okay.
Thank you. Thank you.
Okay. So let's continue here. So you'll see that I have more other types of software installed, and the students can just click there and be able to run. Now, the next step, I'm going to demonstrate how to deploy a container from the scratch. So imagine that the container is not available. Oh, before that, sorry. Okay, here in this example, what I'm demonstrating is how easy it is to start a container, stop, and log into the container. As I said, it takes around 2 to 4 seconds to be able to switch between containers. Okay. Okay, so this is how long it takes to start a container. As you can see, it's very, very quick moving from one place to the other. Here I can demonstrate that because the image is persistent, that the project is there and you can run it at any stage. I'm now going to close the connection and stop the container. Okay, let me quickly go here. So this is what you can find on my Docker Hub page. So you'll have information about how to use and access the Java tools or the C++ tools. So, for example, in this next step, that what I'm going to do is to create a container for my C++ tools. Yes, Benjamin. Yes. And by the way, I'd like to thank Benjamin because he has been doing great help. Benjamin works with us here at NTU and has been giving a big help. So in this case, what I'm doing is to remove that tag, that parameter that removes the persistent image at the end. And as you can see here, it connects automatically to my repository. And when it finishes, depending on the network connection, it gets into this screen here. This means that we are now running on the container. And after that, I can just write exit, and you'll see that the images are now available here. You also see that there are these orange tags that tells you the architecture of the container. So in this example now, I started the container that I developed for teaching C++. And now I'm going to log in into the container. And I use for that RDP into the container. Can see here that I now have Eclipse and all the tools that are required to do the C++ tasks that we have here at Nottingham University. And as you can see, I'm now starting the container with Eclipse. One of the arguments is, why don't you just deploy a container with all of these tools? Well, I'm looking also at the footprint, and for me, it's very important for that my students can download the image that they're looking for in the shortest period of time. So it's much easier to create a container, almost a container for every model, and then they can decide what they want. So here I'm giving an example on how to compile a C++ project. So I just selected Linux VCC, giving a project name. And now create the project. You'll see that this will be created in a different folder. In this case, it's Eclipse workspace. And next step is to build and to run. So selecting C++. And as you can see, there's the hello world. So as you can see, it was very simple to move from one container into the other container. I tried to make this as flexible and simple as possible, because again, it's important for me to deliver a good experience to our students, to make sure that they enjoy working with Docker. At this stage, they are learning new tools, and the last thing that we want is to get them frustrated because they do not enjoy working with those tools because it's too complex or there are other problems. Now I'm going to give an example on how to run one of the containers using QEMU. So you'll be able, for example, the one that I'm going to use is the exact same version, but for ARM64 architecture. Initially, some time ago, it was required to run Docker QEMU, but nowadays the Docker desktop has already this configured. And as you can see here, you'll notice that it will take longer. Okay, so this is still the previous image that was started by the RDP. Takes around probably 6 to 10 seconds to load the container on a different architecture, which is not ideal, but at least allows me to deploy and install new software on that image. So let's wait. As you can see here, it takes more time because QEMU is converting and decoding all instruction to the correct instruction set used by that specific architecture. You can see here that all the tools are available. Again, works slower, but at least allows me to develop a solution for those students that have, for example, I have a Mac M1 or they have a Chromebook, and therefore they will be stuck because they would not be able to run on their machines. They would get frustrated. They would complain because their learning experience was not what they were expecting. Okay, so I'm nearly finishing. Well, in terms of conclusion, it's easy to build, run, and share containers. Okay, this is one of the biggest flexibility is rapidly expanding ecosystem. Nowadays, industry the industry is using the containers to make it flexible, simpler, and to make it more reliable, less vulnerable to attacks. We have much better performance than virtual machines. We have a sustainable way of using the resources offered by the device. Is a layer file system gives you as a Git-like control image, reduces the complexity of system builds, and can be used in higher education to train students and abstract students from installing complex package. Okay. Here is my contact. Again, this is my web page at the NTU. If you have suggestions, ideas, if you want to do partnerships and so on, by all means, do get in touch with me, and I'm happy to take questions.
Thank you very much, Pedro. We've now entered the Q&A portion of today's session. Please raise your hands using Zoom's reactions button, or ask your question in the chat window, and I will read them out for you. Sandeep, please go ahead and ask your question.
Yes, so I was just curious in terms of, it's great the session that you've presented and the use of Docker. So do you find that the resources that you're using tend to evolve with each session that you present? Does that happen a lot?
Yes, so this is giving me the flexibility to explain extremely complex subjects like parallelism and how to make systems work with each other, especially in system software, where I look at the operating system perspective. This allows me to better explain the distributed computing. Also, the coursework allows me to explore, and for example, this academic year, I'm asking the students to develop a cloud-based file storage system, and one of the approaches that I've asked them to consider is imagine a situation where you would like to increase the security of your system without having actually to encrypt, because encrypt has a cost. So one of the solutions that we are proposing is, instead of encrypting, to split the file into chunks and distribute the file across, for example, 4 containers. And unless you know the correct order and you attack all the 5 containers that they are using, if you are an hacker, you won't be able to access the information. So it's a very secure and safe way of storing information, increasing the security without actually having to go into encryption. This allows me to explore and help them to look into much more complex scenarios.
Thank you.
We have a question in the chat window from Dennis. Dennis
Yes.
asks, how does this compare in terms of cost?
I hope I understand your question, Dennis. In terms of cost, do you mean price? Price, this is open source, so there is no cost involved. You have to look into the license. There might be some restrictions about how you use those depends on the application. But I think in terms of cost, in terms of money, is not going to be very high or expensive. Second, if you are speaking about the cost in terms of computational performance, this has been the solution that I came across that is more efficient. So first of all, you don't need to reserve, for example, the memory, and you don't have to allocate CPUs that are only assigned to the virtual machine, which allows you to reduce the consumption of the machine. Also, you are doing a much more efficient way, efficient management of resources, because it becomes elastic. So you need more space. Then you install the package, and the space, it will make use of the space. Did I answer your question, Dennis?
Yes, you did.
Thank you.
Next question is from Benjamin. How long did it take you to discover you can use containers in this way?
Well,
X Windows apps.
Yes. Okay, that's a very good question. Thank you, Ben. In terms of researching, well, I think we started to speak using containers around June, July, and it took me about 5 to 10 days in September to be able to deploy all the system. I was aware that it was possible to run XRDP. At the time, I didn't have a good understanding about how the entry point works, which is a that allows you to. So when you start a container, it only repeats that entry point. So at the time, I didn't quite understood that, and at the beginning, I was getting a black screen, and I thought it was a problem with my installation, and I had to reinstall over and over again. Then I realized that actually that black screen is a consequence of XRDP. So when we RDP into a container, it creates two files to lock and say that there is someone there. So actually what you have to do on the entry point is to remove these two files. And if you do that every time, then you'll be able to access. So it took a little bit of time to understand all of this flexibility, but nowadays I think is very flexible. Did I answer your question, Ben? Okay, I think we can go to the next one. Can you run a simple example in Ubuntu without using a bash? Sorry, I'm not sure if I understand your question. Oh, okay. I may be able to understand. Okay, so if I understand correctly, you are asking me to look at the Docker. Okay, so here, Docker will have all of these built-in functionalities, okay? I'm going to be very honest. I noticed that Docker Desktop consumes more memory. So I've recently started to use the Docker Desktop, and I came across this very cool extension that allows you to monitor the usage and so on. So answering your question, yes, you can use the Docker Desktop to avoid having into the bash. Although because of my background, I really like to use the bash because it's faster. So most of the times I use the bash. I think I've answered your question, correct?
Yes.
Thank you. I've been teaching using the Jupyter Labs. It was an easy install on my machine, but on student laptops, sometimes there are issues, multiple different ones. Would installing Docker and working the way you are help with this? Yes. Here, Benjamin, if you have a microphone, I will probably ask you to comment on this because you have been deploying this on the NTU laptop. So if you can unmute yourself and to comment also on this, it would be great. From my perspective, this has been the easiest year for me in terms of providing support, because at least I have a solution that works on the Mac M1. I remember last academic year, most of my time was saying, oh, sorry, I don't have a solution for you. So you can use this, the Microsoft Azure to run these virtual machines. The problem with Microsoft Azure is that it takes around 15 to 20 minutes just to start the virtual machine, and then to stop, it also takes some time. Okay. Now, okay, so commenting on, okay, so Ben just answered that he is not working. I think I've answered your questions. Yes, so Robert, what I suggest is you can create different flags. Let me see if I can quickly bring an example of my Docker Hub. The way I do this is, and I try to make this very flexible. I think you can see my screen. So you'll see that I will have a tag for each model that I have, or at least I work with some colleagues, and I was able to create different installations. Now, again, you can install everything on your machine. The only issue is if the students are downloading that during the lab, is going to increase the time downloading. So you may want just to have a very minimal installation of what you have. I remember that for the AI model, I think it's for 451. I installed the Anaconda so that they could just launch the Anaconda and have access to all the tools for Anaconda.
All right, that is all we have time for today. I'd just like to say thank you to Pedro, and I will hand over to Bev, who will provide the closing remarks.
Hi everyone, I think that's all switched on now. So yes, thank you very much to Pedro for his interesting talk, and definitely going to see how we can expand that out to different students within the department. Thank you to Paul and Gary for hosting and doing the questions, because unfortunately I couldn't get here at the start. And thank you to every one of you for joining. I hope you found it interesting, and hopefully you'll be able to put it to use as well. So if you are interested in more of our talks or getting involved in the branch, then you can find our website on the BCS website, which is the BCS Notts and Derby. And if you're local and want to get involved in the committee, again, just send us a message, and we can get you involved. Future events, yes, we will have events. We usually do one every month, except for December, July and August. So we will be advertising our January event soon. We're just trying to finalize what we're doing in the first couple of months of next year. So yes, so where do we meet? A lot of our things are still online at the moment. So we have had a couple of live events which we've hosted at NTU's Clifton campus, and we're hoping to kind of increase that out. And we're also hoping that our next committee meeting, we can kind of host it in person as a social somewhere in the centre of Nottingham, probably in January now, because we're getting a little bit close to Christmas for doing anything that. But yes, a lot of things are online. So if you follow our Eventbrite as well, or the website that Gary's linked there, or follow us on LinkedIn as well, you'll be able to find out about what else we're going to be doing in the future. Okay, so yeah, do get in touch if you want to. Otherwise, thank you very much. I hope you all have a really good rest of the evening.